Hey everyone, welcome to Algebra, Section 2.7, Proportions. So in a previous lesson we talked about what's a ratio, and a ratio is just a comparison of two numbers. So typically we express that as a fraction. So when we talk about a proportion, all a proportion is just a comparison of two ratios. So basically it's one fraction equals another fraction. So by the end of this lesson, you should be able to solve proportions. You should be able to solve multi-step proportions. And you should also be able to use proportions to solve word problems. So let's go ahead and get right into things. So here we have two examples of proportions where it's just one fraction equals another fraction. And in this case, let's see, we've got k in the denominator. Over here we have m in the numerator. So it doesn't really matter where the variable is. Anytime you have a proportion, that can be solved in one easy process, and that is cross-multiplying. So let's go ahead and explore that. So if I have 10 over k equals 8 over 4, what I can do is I can cross-multiply. So that means take the numerator from one fraction and multiply the denominator from the other one. So 10 times 4 is 40. And then do it the other way. 8 times k is 8k. Now here's how a lot of people do this, and they get stuck as soon as they do. They go, okay, so 10 times 4 is 40. K times 8 is 8k. Now what do I do? Well, that's the mistake right there, is in the middle of doing this, the equal sign went away. The equal sign should never go away, nor should you have any fractions after you're done cross multiplying. Because it's not 40 over 8k, it should be 40 equals 8k. So anytime you cross multiply, make sure it's always one cross equals the other cross. So in this case, 40 equals 8k. And from there, it's a very simple equation to solve. Divide by 8, and I get 5 equals k. Let's go ahead and do another one. M over 10 equals 10 over 3. So I multiply the 3 in the m, which gives me 3m. Bring down the equal sign. And then 10 times 10 is 100. There we go, no more fractions. So let's finish this up. Let's divide by 3. And I get m equals, now 3 doesn't go evenly into 100, so I am fine if you just leave it as 100 over 3. If that can reduce, go ahead and please do so, but in this case 100 over 3 cannot reduce. So that's my final answer. M equals 100 over 3. Now, not every proportion is going to be as easy to solve, so let's take a look at a few more challenging proportions. So here I have 1 over 3 equals f minus 19 over f. So the process is still the same. I'm still going to cross multiply. 1 times f is just f. And then 3 times f minus 19. I'm going to illustrate this in a way that hopefully will prevent unnecessary mistakes. If I do 3 times f minus 19, notice when I set it up like that, something should automatically spring to your mind. You should look at that and say, oh, I have to distribute. Because if you have more than one term in a numerator or denominator, you can't just do 3 times f and then bring down the 19. That 3 is multiplying everything, the f and the 19. So 3 times f, and 3 times negative 19 is negative 57. So make sure if there's more than one term in the numerator or denominator, make sure you're using the distributive property to get a good equation. Now I need to get all of my variables to one side. So over on the left-hand side, I don't have anything but variables. So I'm going to move this 3f over there, even though it gives me a negative coefficient. So I get negative 2f equals negative 57. Divide by 2. That's going to be, I should have divided by negative 2. That's going to be a positive 57 over 2. Now you might say, can I turn that into a decimal? In this case, a decimal isn't going to hurt anything. That's going to be like, 28.5 or something like that. I'm not going to count that wrong. In the example that we did previously, like 100 over 3, that's going to give me 33.333333. I don't want an ongoing decimal. Okay, if it's going to be a simple decimal, I don't have a problem with it. Otherwise, just leave it as an improper fraction. Let's do another one. So if I do 5 times n minus 18, I have to do 5 times the n and 5 times the negative 18. Bring down the equal sign. 1 times n is just n. And then it's very similar to what we just did. Let's get all the variables to one side. So 5n, I don't have anything but variables over here on the right-hand side. So I'm going to go ahead and subtract 5n. So negative 90 equals negative 4n. Let's divide by negative 4. So those negative 4's cancel out. I get n. 90 divided by 4 is what? Positive 22.5. If you put 22.5, I'd be fine with that. Otherwise, I'm cool with positive 45 over 2. Because 90 over 4 can reduce by 2. All right? Last concept I want you guys to learn, story problems, everybody's favorite. So, step 1 with story problem, you read it. Sanji took a trip to Mexico. Upon leaving, he decided to convert all of his pesos back to dollars. How many dollars did he receive if he exchanged 42.7 pesos at a rate of $3.50 equals 11.1 pesos? All right, so after we've read it, we go back through and try to find some, it says how many dollars. That's our variable. Let's use, you can use whatever letter you want, doesn't really matter. So x equals dollars. So that's what we're trying to find. So how many dollars did he receive? He gave that many pesos at a rate. There we go. Key idea here. They're giving us a rate. And the way we can set that rate up is as a ratio. So $5.30 equals 11.1 pesos. So I'm going to set that up as a fraction. Now, it doesn't matter what order you set it up in. You could put the 11.1 pesos on top and the $5.30 on bottom. It doesn't matter what order you set it up in as long as you follow that same order on your second fraction. So on the numerator, I have dollars, and in the denominator, I have pesos. So when I set up my second fraction, I have to follow that same order. Put the dollars on top and put the pesos on bottom. So how many dollars? I don't know. That's my variable. But he exchanged in 42.7 pesos. Now that's a good setup. Okay, so typically they'll give you some sort of rate, some sort of common exchange. In this case, dollars to pesos. So always set that up first, and then go ahead and follow that exact same pattern for your second fraction. So let's go ahead and solve this. Let's start cross multiplying. Get out that calculator. $5.30 times 42.7. So I get 226.31 equals 11.1x. Divide by 11.1 on both sides. And I get 20.3882883. Now again, I don't want some nasty, ugly decimal. So let's make sure that this makes sense in context of what we're doing. If we're going to the bank and we're exchanging our pesos, are they going to say, here's 20.338 or 20.3882883 No, if it's money, we're going to round it to 2 decimal places. So Asanji is going to get back $20 and probably 39 cents. So remember, since it's a story problem, let's put it in context. So he's going to get back $20.39. So that many dollars for his pesos. Let's try another one. It says 3 pumps can remove a total of 1,700 gallons of water per minute from a flooded mine shaft. If engineers want to remove at least 5,500 gallons per minute, how many pumps will they need operating? So once we read the problem, find our variable, how many pumps will they need? So let's do P equals pumps. It says 3 pumps can remove a total of 1,700 gallons. So right there, there's your rate. So 3 over 1,700. Now just to make sure that I'm setting things up right way, I'm going to go ahead and label these. So 3 is the number of pumps, and 1,700 is the number of gallons of water that they move. So when I set up my second fraction, I'm going to make sure to put the number of pumps in the numerator and the number of gallons in the denominator. So if they want to remove 5,500 gallons per minute, how many pumps? Well, that's my variable, the number of pumps in the numerator and the number of gallons in the denominator. So that's a good setup. Let's go ahead and cross multiply. 3 times 5,500, I believe that's going to be 165,000. Bring down the equal sign. 1,700p. Let's solve by dividing by 1,700 on both sides. Whip out your trusty calculator. So 16500 divided by 1,700. So I get 9.705 equals P. So, put this in context. Are they going to, the engineers going to use 9.7 pumps to get out all that water? No, it says they want to remove at least that much. Could they remove more? Yeah, they could. If we rounded that to 9, they wouldn't quite get to 55,000 or 5,500. So, in context of our story problem, we can say they will use 10 pumps. All right, let's do one more example. So a map of Connecticut is drawn to scale where 2 inches on the map represents 35 miles. If Greenwich and Stonington are 105 miles from each other, how far apart are they on the map? Okay, so let's see, how far apart? Let's say x equals distance on map. So they start off with a conversion factor there, a rate, if you will. So a map of Connecticut is drawn to scale where 2 inches represents 35 miles. Okay, now just to keep things straight, I'm going to go ahead and label that 2 inches is on the map, and the 35 miles is in real life. So when I set up my second fraction, says how far apart do they appear on the map? I have no idea, so that's my variable. But in real life, they're 105 miles from each other. Notice I even put the labels on there, inches and miles. That's a good way to verify that you've got things lined up correctly. So let's go ahead and cross multiply. So 2 times 105 is 210. X times 35 is 35x. Divide both sides by 35. And I believe that 210 divided by 35 is 6. So how far apart are they on the map? I would say 6 inches apart on the map. All right, hopefully that wasn't too bad for you guys. If you have any questions, please feel free to email me or ask me questions in class. And I will see you guys real soon. Hope you enjoyed your Labor Day. Have a good one. Bye.